Bismillahirrahmanirrahim. Quote of the day is, with the new day comes new strength and new thoughts. Assalamu alaikum. My name is Dr. Momena Zia. I am an MPhil trainee in Community Medicine Department, and I'm going to present the topic of ways of presenting data under kind supervision of my supervisor, Professor Dr. Syed Afsan. Learning outlines will be data and its types, general methods of data presentation, use of numbers in organizing data, tables, charts/graphs, diagrams, box and whisker plots, stem and leaf plot, MCQs. By the end of this presentation, the participants will be able to describe different methods of presenting data. What is data? Any piece of information that can be measured, like height and weight, judged as age about 50 years, assessed as malnourished, or observed as yellow discoloration of skin, is known as data. Data has different types. It can be qualitative and quantitative, which can be further divided as qualitative data is divided as nominal data and ordinal data, and quantitative data is divided as discrete data and continuous data. Now, what is a nominal data? It can be labeled or classified into mutually exclusive categories within a variable. For example, if we consider mode of transportation, then we have categories as car, bus, train, and bicycle, etc. Similarly, if the similar data is categorized in a specific order, then it becomes ordinal data. Moving on to the quantitative data, the discrete data is the information that is countable, distinct, and separate, and it can take on specific finite values with no intermediate values between them is known as a discrete data. Figures 1, 2, 3, 4, 5, these are the discrete data. Now moving on to the continuous data, the data that can take any value and is continuous. Examples are height, weight, temperature, length, etc. Now, there are three general ways of presenting data. One is numerical methods, two is in the form of tables, and three is in the form of graphs, charts, and diagrams. So moving on to the first method, use of numbers in organizing data, nominal numbers. So the numbers that do not represent amount or quantity, these are used to identify a person's status, category, or attribute, and they are used for nominal data. For example, a table is shown, which in one column a serial number is there, and the other column shows the smoking status of that person in the form of nominal numbers. Serial number 1 has the smoking status of 1, 2 has 2, 3 has 1. And on the bottom, we can see that the 1 is static with 1 shows smokers, and 2 is static shows the status as non-smokers. So these are the nominal numbers. One important thing is mean of nominal numbers, they cannot be computed. Moving on to the ordinal numbers. So these numbers, they represent an ordered series of relationship. In example, given below, educational status numbers or ordinal numbers, 1, 2, 3, and 4. Ordinal numbers, they only indicate the position in an ordered series, but says nothing about magnitude of difference between two successive entries. Example is the table, which shows the respondents' educational status numbers against the serial number. So first shows the educational status of 4, second 1, 3, 3, and 4, 2. And on the other side, we see that there is the order in these numbers. 1 represents illiterate, 2 represents matric, 3 represents graduate, and 4 represents postgraduate. Moving on to the other method of measuring is interval scale. Interval scale involves assigning numbers of equal intervals from an arbitrary origin. The arbitrarily selected origin 0 point, it does not imply a true absence of characteristic, means the 0 point is a false 0 point. Examples are Fahrenheit and Celsius temperature scales. Because interval scales, they don't have an absolute zero ratios of scores, they are not meaningful. 60 degrees Celsius is not double as hot as 30 degrees Celsius because 0 degrees Celsius, it does not indicate a complete absence of heat. Another example would be the pH scale. Moving on to the ratio scale, it is different from that of the interval scale in terms that it has a true 0 point, which reflects the absence of a measured characteristic. So it means when the variable is 0, there is none of that variable present. Example is blood pressure, age, body weight, all are ratio scale variables. Number 2 is the presenting data in form of tables. We have simple tables, we have frequency distribution tables, and we have cumulative frequency table. And number four is relative frequency table. This is an example of presentation of data in the form of a simple table, which shows method of delivery of 250 babies born in a hospital in July 2013. So this table shows that 180 babies were born by normal method of delivery, 60 were born by C-section, and 10 by forceps. So this is a simple method of displaying data. Another one is frequency distribution table. So this table represents the frequency of frequency in data. And by means of frequency, we mean that the number of times the value occurs in the data. This frequency distribution table represents the organizing of raw data of quantitative variables. And this table shows the various values of a variable, how they are distributed and their corresponding frequencies. This can be seen in this table, which shows the marks scored by students in a nursing class in 2013. On an extreme left, we have the column which shows the marks scored by students. The class intervals are made here, 41 to 49, and similarly 77 to 85. The other one shows the tally marks, and the last one shows the frequency. 41 to 49 marks were scored by 3 students. And at the bottom, we can see the total frequency of the table. What are the merits of frequency distribution table? In a glance, it shows where the main concentration of value lies. So it shows the range and shape of distribution, and it is also used for descriptive summaries of both quantitative and qualitative data. Moving on to cumulative frequency table, as the name suggests, this table tells us the cumulative frequencies, additional frequencies, below the upper limit of the class. Cumulative frequency table shows us the number of frequencies individuals having a measurement less than or equal to the upper boundary of the class interval. Cumulative frequency is required to calculate the median of a group data, and it is also required for constructing cumulative frequency polygon, which will we see later. So this is an example of cumulative frequency distribution table. We see that it has a class interval column, tally marks, and frequency. Another additional cumulative frequency column is here. What we do is we add the value which is present in the upper row with that of the lower ones. In case of 20 to 30, we see the cumulative frequency remains 2, which is similar to that of the frequency. But in this case of second class interval, which is 30 to 40, the cumulative frequency becomes 6, which is the addition of 4 into 2, 4 plus 2. Similarly, by adding this 6, in this 6, we get 12. And this goes on. Now, the relative frequency table. So many researchers, they prefer to work with a relative frequency distribution that contains percentages or proportionate frequencies rather than raw frequencies. Relative frequencies must be used when data sets with different sample sizes are compared. So relative frequency table, it can be calculated by a formula, which is subgroup frequency divided by total frequency into 100. We see in this case, we have the ages in years, the class intervals is there, the tallies and the frequencies. Now we have to calculate the relative frequency. The formula is we divide the subgroup frequency by total frequency into 100. So in this case, 11 divided by 25 into 100 turns out 44, which is the relative frequency of this class. Now, bar charts. They are useful methods of presenting data by the length of the bars, and they are frequently used because they are better retained in the memory, they have a powerful impact, they are an easy way of expressing statistical data of nominal or ordinal variables. Categories or variables are displayed as rectangles of equal width with height proportional to the frequency of the variables. So this is a bar chart which shows the admission from January to May in a hospital of Rawalpindi. We have months along the x-axis and frequency along the y-axis. Maximum admissions in April and the minimum in January. Another form of bar chart is multiple bar charts, and this shows 2 or more bars pertaining to the same category and can be grouped together for better and easy understanding. For example, if we want to express the number of students, both boys and girls in each group in the class, we can form a multiple bar chart. So in this example, we can see boys in orange color and girls in blue color in each group. So we can see that group A, group B, and group C boys are dominating in the classes, and as compared to the group D, in which girls are more and boys are less. So this is an easy way of comprehending data. Now, component bar charts. The simple bars, they are divided into two or more components. Each part represents a certain variable proportional to the magnitude of that variable. These are called component or stacked bar charts. So this is an example which shows the component bar diagram for expenditure of School 1 and School 2. In School 1, the expenditures include library, watering plants, laboratory, computers, and construction repairs. So each of the school they have there, they show the certain magnitude of that variable, part of that variable, and forms the component bar chart. Now the pie chart, it is a circular chart and shows differences in frequencies or percentages between categories. The area of a pie is taken as 360-degree, representing relative frequencies in wedge-shaped proportions. It is used for qualitative data. So this figure shows the gender distribution of between children. 50.18 shows the children are female and 49.82% are males. So this can be easily comprehended by forming a pie chart. Now moving on to histogram, the frequently used for quantitative data. It consists of a series of adjacent bars. The height of each bar indicates the frequency. X-axis contains quantitative value of variable of interest, and Y-axis depicts the frequency. A gap only exists if a class interval has zero frequency. So this is an example of a histogram. This histogram shows age versus frequency, and the other one shows the height versus frequency. So we are calculating we are seeing the heights of black cherry trees. The maximum height is seen around 75 to 80 feet. And along 10 of the trees have this height. And in this case of age, we can see that the age of a person, 50 to 60 is the maximum value. Frequency polygon. It is appropriate for quantitative data. X-axis contains numerical value of variable and Y-axis represents the frequency. It is constructed by joining the midpoint of each class interval of a histogram. It is constructed by plotting the midpoints of each class interval with the corresponding frequency and then by connecting these points with each other by a straight line. So the midpoints are obtained in a histogram, then they are joined to form a frequency polygon. So this is how we convert a histogram into a frequency polygon. Another one is cumulative frequency polygon or ogive. To construct this, an ordinary frequency table has to be converted into a cumulative frequency table. We place a point at the upper class boundary of each class interval in front of the corresponding cumulative frequency. So it is completed by connecting all the points with a freehand cuff. Percentiles may be obtained from an ogive. On x-axis, the values of the variables, and y-axis, the cumulative frequencies can be obtained, and it resembles the English letter S. Another way of presenting data is by pictogram. As the name suggests, it is the pictorial presentation of data for easy understanding of a common man. So this example shows the fruits and the number of children who chose it. So pears, watermelons, orange, apple, and bananas are in the fruit section, and the number of children who chose it, 7 children chose pears, and while one chose watermelon, and the similar with the other fruits. Now, line diagram is another way of representing data. It is used to show the trends of events with the passage of time. The important thing is it shows the events with the passage of time, means it predicts over the period of time. So future predictions, they can be presented efficiently in this type of presentations. So the figure, it shows the trends of profits for a company in the coming years. Another important way of presenting data is by means of scatter diagram. A scatter diagram is used to examine the relationship between both the axes y and x and y with one variable. In the graph, if the variables are correlated, then the point drops along a curve or line. A scatter diagram or scatter plot gives an idea of the nature of the relationship. So in a scatter correlation diagram, if all the points they stretch in one line, then the correlation is perfect and is in unity. However, if the scatter points are widely scattered throughout the line, then the correlation is said to be low. If the stem points rest
पे
near
तो
a
सही नहीं
line
बनता
or a line, then the correlation is said to be linear.
क्या नहीं
So these are the examples. These the points are resting on a line. So this shows a perfect positive correlation. And this one shows the direction is opposite. So it shows the perfect negative correlation. So high degree of positive correlation is represented by this graph. And this shows a high degree of negative correlation. Whereas no correlation can be shown by means of these graphs. Stem and leaf plot. A stem and leaf plot is a special table where each data value is split into a stem, the first digit, and a leaf, usually the last digit. Example, 32 is split into 3, which is stem, and 2, which is the leaf. More examples include, for the other ones, 156, 1 is stem and 56 is leaf, which means 15. Stem 1, leaf 6 means 16. Stem 2 and leaf 1 means 21. Now moving on to box and whisker plot. A box and whisker plot is defined as a graphical method of displaying variation in a set of data. In most of the cases, a histogram analysis provides a sufficient display, but a box and whisker plot can provide additional detail while allowing multiple sets of data to be displayed in the same graph. Box and whisker plots are very effective and easy to read as they can summarize data from multiple sources and display the results in a single graph. Box and whisker plots allow for comparison of data from different categories for easier and more effective decision making. So these are the components of a box and whisker plot. A box and a whisker plot, also known as box plot, shows the 5-number summary of a set of a data. Number 1 is minimum, which is the smallest value in the data set. 2 is lower quartile, which is Q1, and it is the median of the lower half of the data. Third is median, which is the which can be denoted by Q2, the middle value of the entire data set. Another one is upper quartile, which is Q3, which is the median of the upper half of the data. And then is the max, which is the maximum value in the data set. Between Q1 and Q3 lies the interquartile range. Box and whisker plots, these are useful for visualizing the distribution of data, comparing different data sets, and identifying potential outliers. Now reset advances. Beyond bar and line graphs, time for a new data presentation paradigm. So the abstract is, figures in scientific publications are critically important because they often show the data supporting key findings. Our systematic review of research articles published in top physiology journals suggests that as scientists, we urgently need to change our practices for presenting continuous data in small sample size studies. Papers rarely include scatter plots, box plots, and histograms that allow readers to critically evaluate the full data may suggest different conclusions from the summary statistics. We recommend training investigations in data presentation, encouraging a more complete presentation of data and changing journal editorial policies. Investigators can quickly make univariate scatter plots for small sample size studies using our Excel template. Now, moving on to the MCQ section. A researcher wants to graphically represent gender distribution in the study. Which of the following is the most appropriate method? A, histogram, B, frequency polygon, C, ogive, D, pie chart, E, scatter plot.
pie chart
Yes, pie chart is the correct answer. 2, a researcher wants to present the world population estimates in millions for 10,000 BC to 2050 AD. The most accurate way of presenting this data would be A, pie chart, B, bar graph, C, scatter diagram, D, line diagram, E, stem and leaf plot. So the answer is yes, D, line diagram. 3, a researcher wants to compare distribution of data of 3 studies in which weight of the children are taken. The best method to compare distribution of data set will be A, bar charts, B, box and whisker plot, C, stem and leaf plot, D, scatter plot, E, line diagram.
Bar chart.
A,
Stem
bar
and leaf.
chart. Bar chart.
The answer is box and whisker plot. There are multiple studies included. We have said that if the multiple studies are included, we can easily visualize forming a box and whisker plot. Multiple bar charts. If the option was multiple bar charts, then we choose option A. 4. As a public health expert, you want to show that 1 in 7 women suffer from breast cancer in a rural community. The best method to raise awareness in the community by posters will be A, bar chart, B, histogram, C, pictogram, D, area map, E, stem and leaf plot.
Pictogram.
Yes, pictogram is the answer. Number 5, which of the following is the interpretation of the scatter plot given below? A, strong positive correlation, B, strong negative correlation, C, no correlation, D, positive correlation, E, negative correlation.
Strong positive.
Correlation.
Yes, strong positive correlation. Yes, strong positive correlation is the answer. 6, a student graphically represented distribution of age in study by bars with no distance between the bars. After that, he joined the midpoints of all the bars to make a curve. Which of the following curves would have been drawn? A, ogive, B, frequency polygon, C, scatter plot, D, line diagram, E, stem and leaf plot.
Frequency polygon.
Yes, frequency polygon is the answer. 7, the diagram shows the transaction amounts per customers in front of the corresponding cumulative frequency. What is the following diagram called? A, frequency polygon, B, ogive, C, line diagram, D, scatter plot, E, box and whisker plot.
Line diagram.
Line diagram.
No, this is not the line diagram.
Frequency.
Yes. No, this is the ogive.
Scatter plot. D, ogive.
It is the graph between the variable and cumulative frequencies. So this is the cumulative frequency polygon, which is ogive. 8. A suitable diagram to represent the data relating to the monthly expenditure on different items by a family. It can be shown by A, bar chart, B, pie chart, C, histogram, D, compound bar chart, E, stacked bar chart.
D, compound bar chart.
Stacked bar chart.
Pie chart. Pie chart.
Yes, pie
Pie.
chart. Pie chart is the answer.
Pie chart.
9. In a cumulative frequency polygon, the cumulative frequency of each class is plotted against A, midpoint, B, upper class limit, C, upper class boundary, D, lower class limit, E, lower class boundary.
C.
Yes, C is the correct answer. 10. A stem and a leaf plot of number of hospital admissions per day is shown. List the data values for the given stem and leaf plot. A, 2, 5, 25, 30, 42, 52, 70, 80. B, 3, 7, 8, 24, 25, 45, 52. C, 3, 7, 8, 24, 25, 40, 45, 52. D, 4, 7, 30, 20, 25. And E, 24, 25, 40, 45, 52. Anyone? Charlie is the correct answer. What we do is we are going to show the first digit. Stems will be shown as first digits and leaf will be shown as second digits. Like 03 becomes 3, 07 becomes 7, 08 becomes 8. Then becomes 24 and 25, then 40 and 45, then 52. And this set of values are present in Charlie. So this is the key of the MCQs. This is the reference from which the presentation is made. This is the channel where the presentation will be uploaded shortly. And thank you for your cooperation.
Thank you.
Thank you.